Hi guys, while I'm at home recovering from my surgery, your lessons are going to be on YouTube. So what I've decided to do is while I'm out, we are going to forego the remaining of chapter 3, and we will resume that when I get back into class because of the complexity of it, a lot of story problems. It's a lot more difficult of a concept to try to convey well over a YouTube video. So we are in chapter 4. Now, what I'd like you to do as you watch all these videos is follow along in the book, because I will be using the examples in the book and talking through them just like I would in class. And then at the end of each video lesson, you will be given your homework assignment, okay? And the sub will also have that information for you. So in 4.1, we start with inequalities. So inequalities are things like greater than, less than, greater than or equal to, less than or equal to, or not equal to. So when it comes to graphing these things, what we need to realize is the difference between whether a hole is open or whether a hole is closed is if you've got this line underneath your inequality symbol. If the line is there, that means that the hole above the number in question on your number line is filled in. Whereas if you are missing that line, that equals line, your hole remains open. Okay, so this starts very, very simply. Thankfully, the beginning of every chapter is pretty manageable. The hardest example to follow is example 1. We are on page 144. It says state an inequality equivalent to. Okay, here's what they give us. X is not less than or equal to Y. So what we need to do is negate everything, okay? So if it is not less than, it's greater than. And if it's not equal to, so if X is not less than or equal to, it is simply greater than. Let's do another one. If X is not greater than Y, that means that X is less than Y. If X is not greater than or equal to Y, that means the total opposite of all of that is that X is less than Y. A more simpler case, to negate X is equal to Y, the negation of that, of course, is X is not equal to Y. Now, to be perfectly honest, I'm not exactly sure the reasoning for needing to know the negation other than understanding the original inequality symbol. So if you understand greater than or equal to, you know that it is not less than, okay? So as far as example 1 goes, we're just able to look at the negation of the inequality to state what the opposite of that is. Okay, now let's get down to the good stuff. So example 2, basically what we're doing here is solving one-step inequalities. But if you notice in particular, for example 2, we are given an inequality, and then we need to determine which of the following are solutions. So before we begin to solve these, we are given a specific domain. In this case, for example 2, it's 2, 3, and 4. So they give us a plus 3 is greater than 6. So we can say a plus 3 is greater than 6. So when it says determine which of the following are solutions, of course, we are going to take each number in the domain individually and plug it in for our variable to determine the truth value of that inequality. So 2 plus 3, is that greater than 6? No. Is 3 plus 3 greater than 6? Now, 6 is not greater than 6. If we had greater than or equal to, then it would be true. But 6 is not greater than 6. 4 plus 3, is that greater than 6? Yes, it is. So we could also do the same thing for an example like example 2b. 6 greater than or equal to 2b. So not only do we have the option to say that 6 is greater than 2 times whatever our domain is, we can also say that it works if it's equal to as well. So 6 greater than or equal to 2 times 2, yes, 6 is greater than 4. It doesn't have to be equal to 4. It has to be greater than or equal to. 6 greater than or equal to 2 times 3. Yes, it is, because 6 is equal to 6. And then, of course, the last number in our domain that we test is 4. Is 6 greater than or equal to 8? Definitely not. Okay? Now the last one involves a negation. All right, so instead of looking at the negation statement, we're going to rewrite that. So if we have 1 minus c is not less than negative 2, that must mean that 1 minus c is greater than negative 2. So that right there is the inequality statement that we're going to use to plug in each one of our domain values. So is 1 minus 2 greater than negative 2? Is negative 1 greater than negative 2? Yes, it is. Then we would do the same thing for 3 and 4. If we put a 3 in, is 1 minus 3 greater than negative 2? In other words, is negative 2 greater than negative 2? Definitely not. Okay, the last one is 1 minus 4 greater than negative 2? In other words, is negative 3 greater than negative 2? And no, it is not. Okay, so when you have a negation sign, it would be helpful to rewrite the inequality with the opposite. So in this case, 1 minus c is not greater than negative 2 can be rewritten as 1 minus c is greater than negative 2. That's what you plug your domain values into, and then it makes it very, very simple. This is the point where if I was in class, I'd look at you guys and say, are you with me so far? Okay. Now moving on to example 3. Here is where we start graphing. And when we graph an inequality, we have to pay attention to whether the inequality symbol has an open or a closed hole according to whether or not the inequality has the line underneath it or not. So I'm going to give you a couple of examples that are not like the one in example 3. So we need to graph x is greater than 4, and then we are going to graph x is greater than or equal to 4. Now my advice to you is, instead of making a whole huge number line with every number in the world on it, all that really matters is that number right there. Okay, so I'm just going to put that number right smack dab in the middle of that number line. And all of the numbers that are greater or bigger than 4, we know go to the right of 4. Okay? So, because there is no line under my equality symbol, when I make the open hole over the 4, I'm going to leave it open. And the numbers greater than 4, the numbers bigger than 4, go that way, to the right of 4. Okay, so let's look at x is greater than or equal to 4. Okay, same idea. I'm going to put the only number I need is 4. And I'm going to put my open hole above there. And because of the line under the inequality, this time it is going to be colored in. Okay, meaning the solution set includes the number 4. Whereas over here on the left, the solution set does not include the number 4. It includes everything above 4, like say 4.01, etc., but it does not include the 4. So if x is greater than or equal to 4, it includes the 4, and all of the numbers greater than are to the right. That's the only difference, is the line under the inequality symbol. Now we could do the same thing with, let's say x is less than 5. X is less than or equal to 5. And then we'll also graph x is not equal to 5. And that is an interesting graph. Okay, so I'm kind of off center. So we're going to start the first graph over here. This is x is less than 5. So I put my 5 in the middle of my number line, open hole, and that is right now at the point I need to decide, am I filling it in or not? I'm not, because of the missing line underneath my inequality symbol, and the numbers less than 5 are definitely to the left. So they would be all the numbers forever to the left of 5. But if x is less than or equal to 5, I have to draw my circle and decide whether I'm filling it in or not. If x is less than or equal to 5, I am including 5 in my solution. And of course, all the numbers that are less than 5, including 5, go to the left. Okay, now if x is not equal to 5, 5 is the only number in the whole world that x is not equal to, okay? So again, I put an open hole over my 5, but if x is every number in the world except 5, that means I get to go that way and that way, because I can have numbers less than 5, I can have numbers greater than 5, I just cannot have x equal 5. And not equal to is an inequality symbol. We don't see it that often, but it is an inequality symbol. Equals and does not equal are inequality symbols. Okay, so what we're going to do now is look at example 5. Okay, it says write an inequality to describe the following graph. Okay, so I'm going to give you a couple of my own here. Okay, so we're going to have 3. We're going to go that way. Then another one. I'm going to put 10. And we're going to go that way. Then let's say -2. And we've got that graph right there. Okay, so looking at the one on the top, I know that x represents the solution set and the number in question is 3. Now I'm looking to all of the numbers that are less than 3, following the arrow. All the numbers to the left of 3 are less than 3. So I use my less than inequality symbol, and because my hole is open, I do not put my equals under the inequality, and I am done with that inequality statement. Looking at the one on the lower left, I know that my solutions are X. X represents all the solutions. The number in question is a 10. Now I'm going towards the right, to the right of 10. Well, to the right of 10 is 11, 12, 13, etc. Those numbers are greater than 10. Now, because the hole above the 10 is filled in, I have X is greater than or equal to 10. Okay? Then the last one, I know X represents all the solutions in the set, and the number in question is -2. Well, it appears that every number to the left of -2 works. Every number to the right of -2 works. The only number that doesn't work is -2. So in other words, X could be every number in the world except for -2. So X does not equal -2 represents that graph on the lower right. Okay? So as far as that lesson goes, we are looking at IXL only. Your homework will be IXL F1 and F3. And then you will have another video assignment on Tuesday that is over 4.2 and another IXL homework set. Okay. If you have any questions, you can email me. You can talk to Mr. Most. He is in regular contact with me, or your sub. See you guys. Bye.